Okay, question 7. When you're looking down and you're scanning this, you just notice the big chunk of question 7 that just looks quite horrid. But when you get there, it's okay. So try not to be put off and just do what you know. So the first bit is really straightforward. It just asks us to tell them the centre of this. Yeah? Well, the centre of the circle, remember, we complete the square for it. So x, half this coefficient, this plus 4 to plus 2, square it, take the plus 2 squared away, then plus y, and then half that minus 3, square the whole bracket, take away the 9, that's still equal to 7. Now, in order to answer this question, I don't actually need to tidy that up. I can say the centre is at minus 2, 3. So, it then asks me to go on to II says, find the radius, and what's in the form k root 5. Okay, well, the radius is all the numbers on that side. So this side I had minus 4, minus 9, and then I had equals 7. Yeah? But obviously the bits thrown in, so they need to go that way, that's negative 13, so that will be equal to 20 on that side. So I can say the radius is equal to root 20, which I know I can simplify to root 4 times by root 5. Root 4, that's square roots to 2 root 5, and I've got that. In part B, it brought in a nice new bit. It told us that y for a particular line is equal to mx minus 3. It told us this line was intersecting with our circle. Now, this is in y equals, so it's really straightforward subbing, but it's making sure we choose the right one. If I choose this one, first off I know it's 100% right. Yeah, it's the original in the question. Second, I'm not having to expand brackets or worry too much about that. So I'm going to go with subbing this into the original. X squared plus y squared plus 4x minus 6y equals 7. So we've got x squared plus mx minus 3 all squared plus 4 lots of x minus 6 lots of mx minus 3. Now, I know it wants me to make it equal to 0, so I'm going to bring a 7 across before I start. Minus 7 equals 0. Okay, so I've got x squared. From this, when I multiply this by itself, I'm going to get m squared, x squared. Positive. Then, these two are going to be multiplied together, which will be minus 3mx, but I'm going to get that twice, it's going to be minus 6mx. And then I get minus 3 squared plus 9 plus 4x, which was there, and then minus 6mx again. And then minus 6 times by minus 3 plus 18 minus 7 equals 0. Now, I now want to try and group the like terms. So I want all the x's together, I want all the x squareds together, and I want all the constants down that end. So I've already got the x squareds together, so I'm just going to rewrite them for the moment. Then I've got minus 6mx plus 4x minus 6mx. And then my numbers, plus 9 plus 18 minus 7 equals 0. So, I can see here that x squared can come out both terms. So I'd have 1 plus m squared, lots of x squared. Then, I've got minus 6mx and minus 6mx. So here I've actually got minus 12mx plus 4mx, or 4x, sorry. So, from these two terms, I can take out 4x. So I can take out plus 4x which would leave me 1 from the 4x which was there, and then when I'm taking the 4x out of this term, it's going to give me minus 3m. I've got 9 and 18, 27, minus 7, plus 20 equals 0. Now, I like to factorise it as I see fit and then look at the example. Now, with them, they've taken the 4 on one side and the x on the other, so I can now just say, therefore, it does go to 1 plus m squared, lots of x squared, plus 4 lots of 1 minus 3m x plus 20 equals 0. Boom. Yeah? And realistically, it doesn't feel as nice, but the maths in it, the numbers in it aren't too bad. It's just been really, they've given me another proof. Yeah? So, they basically said, show that the quadratic equation, this one here, has equal roots when? So, has equal roots. Again, roots is screaming at me to say, okay, well I need b squared minus 4ac. Now, they've specified has equal roots, so I know I need to equal that to 0. So, looking at the bit above, yeah, this bit here, that's all my b. This bit here, that's all my a. And then obviously this bit is my c. Yeah. So, I'm interested in... Now, I like to use a nice square bracket for this, because I want to square the whole thing. Then I want to minus 4 lots of a, 1 plus m squared, and then I want to times that by 20 as well. Now, if it's got equal roots, that equals 0. So, I'm just going to square this square bracket first. So that's going to give me 16, and then it's going to give me 1 minus 3m all squared. Then it's going to give me minus, 4 times 20 gives me minus 80, and then again it's going to give me 1 plus m squared equals 0. Now, this is really, really common. In discriminant questions, they love to give you a number in front of your brackets, and they'd love to see you multiply that out all awkwardly and get these huge numbers which you just have to divide down. Divide down now. We know they're both divisible by 4, but better than that, they're both divisible by 16. So that would leave me here 1 minus 3m all squared minus, well, 80 divided by 16 is 5, lots of 1 plus m squared. And suddenly, something that was looking quite nasty has become really simple. Now, just got to go careful, take my time, and make sure I expand all of this correctly. So, 1 squared is 1. These two multiplied together is minus 3m. I got that twice, so that's minus 6m. And then this squared plus 9m squared. Minus 5 times by the 1, minus 5. Minus 5 times by the m squared, minus 5m squared, still equals 0. Now group my terms, so I've got 9m squared minus 5m squared, 4m squared. I've got minus 6m. And then I've got 1 minus 5 minus 4 equals 0. Now because it's equal to 0, I know that. I can divide that through by the 2. So therefore, 2m squared minus 3m minus 2 equals 0, which is what they've asked me to show. The final part. I. So many i's. Says, hence find the values of m for which the line is a tangent. Well, for a line to be a tangent, it must touch. It must have equal roots. So, b squared minus 4ac must be equal to 0 for tangents. Yeah? So, we know this, yeah? if we just factorise this, these values of m which solve this equal to 0 are values of m which allow it to be a tangent as well. So 2m squared minus 3m minus 2, factorise 2m, options of making minus 2, 2 and 1, yeah? Now I need 2 and 1, I need more negatives, so I need to make that negative, this plus, that means m equals minus a half, m equals 2. Those are my two values for m, for which, remember always write that equal to 0, that's a bit naughty. Those are my two values for m, for which the line is a tangent. That's question 7.